So, so this is the thing. Last we discussed about the 32-bit ALU preprocessor and theory part only. So this time we will discuss about the Verilog implementation of this project. Before that, here you can see that these are the definitions as I discussed in last video also. So these are the definitions means if you are using and as an keyword, so it is defined as a 3-bit 100. So it is useful for to select the operation. So depend upon the operation of these bits, so you can write keywords. So I request you to study about the define how you can define in the Verilog this types. So it is simpler only, not that much difficult to study. So coming to the Verilog ISC design suite also to verify this logic. So custom is like for verification, but to check with the test bench you can use both Vivado and ISC. So now I am going to implement in the costas image. It is a paid version that you can get for the cracked also. So in costas I just open. So the first file is, so these are the files which I done for this project. So don't worry, I will explain each and every file. This file is regarding about the definitions of your project. So it is already defined that a project you have the different definitions. So these are the definitions which already we gave. So these are the definitions which I already gave. Just copy and paste the definitions in one file and give a meaningful name to this file. Like I gave here, define.v. That means .v is the extension of the Verilog. So you give the .v for this file. Just copy and paste and give the define.v as your file name. So we gave definitions. So wherever you can use, you can call that file. So now my next aim is to develop a. So first, what's your idea to write a program is? First, you have to know how many block diagrams you have and sub block diagrams also. So you have your top module and you have a executive preprocessor first block, second is ALU block, and in ALU block you have the sub block called arithmetic shift, arithmetic shift ALU. So totally 1, 2, 3, 4. 4 blocks with one top module. Okay, so we'll go block by block design. So if you completed one block, you make it into a separate file. So we will write block by block as a program. So first we will start with executive preprocessor first block. So before that I have to write top module because this is the top module. I have to say this is the top module first thing. Then within this top module I have two sub blocks and within the sub block I have another two. So like that. First I will start with top module. So we know that top module we have input signals and two output signals. Just describe that into the file. So my file is enhanced ALU. So before that you have to include this define because we are using in the modules. So better to define that in ALU. So first we have to define this one. So you know that this is a comment line. So these are later you can understand these two why I kept because this top module have two submodules. One is preprocessor and one is ALU. So I am writing in a separate file. So I am calling that file into top module so that it will execute. That for the compilation process you no need to compile separately. So compiler will compile this one, compiler will compile this one, compiler will do this one. So it will understand the whole submodule. So top module will execute by the compiler. So to have compiler understandation, we are giving this include. So we giving the enhanced ALU as a module name. So we have this clock reset or the event specification. So clock reset enables SRC1 immediate. So memory reading controlling. So controlling, I just magnify. So we can so we called it as wires and we give the actual length what are the wires it should be. So the top module is completed. So we will go for the next. So next is preprocessor. So write in a separate file. Here also I am using the definition, so I include definitions. My module name is preprocessor. So according to the preprocessor only, I called in the main module also instantiation. So here preprocessor I declared the whatever the input signals and output signals described in the function. So here this is my system specification of the executive preprocessor. So what I'm going to do is this is the combinational behavior. So here you can write it as an top module also, not a problem. So I am writing in the preprocessor block. Here it is showing that SRC2, whatever the SRC2 is going out to the memory readout. But that memory readout is depending upon the memory writing enable. But here it is not given. But if it is memory writing is enabled, then this data will come out. So here I am writing. So memory write out is depending upon the memory read enable. If it is 1, it will give the SRC2, otherwise it will give to 0. Okay. So next one, memory read enable. So how it will works. So first signal is over, next signal is. So it is like a marks 2:1 marks. It is depending upon the select line and this is the select line. So we define the same thing. So it is depending upon the select line. So read enable. So on this one, this is 1. So combining both things, we will get the enable. Okay, because there is no need of sending 0 and 1, we can directly multiply this thing. You will get the select line. So understand, you can put otherwise this is like full select line. You can whatever the select line that is coming out of this logic, because there is no need of 0 and 1. Whatever the select line, it is coming to the memory read enable. So here we come to the reset behavior. This is actually preprocessor everything. So this preprocessor, what is reset behavior? It shows the reset behavior. So here this is a sequential circuit of preprocessor because it depends upon the clock. So we are giving a asynchronous reset. So the sequential block is depending upon the clock, so there is a need reset. So what are the signals should 0 is given in the description of the reset behavior. So these signals will get 0 resetted in the preprocessor. Similarly, we have to start here. Reset is over. Once reset is over, the real behavior of preprocessor will start work. So here you see that the signals of the preprocessor. So it depending upon the mostly. First of all, you have to start with the left side, most left side. It starts with the enable X. So if it is enable X is 0 or 1, some operations are going on. So you can see enable X is the main thing to select the operation or mention. So output just depends upon the enable X. That means because this enable X will active the preprocessor. So due to that only output will come. So if it is not active, so these are the signals we have to get it out from the description. So if it is 0, so operation out will be no change, operation out is no change. So if it is 0, ALU is no change, ALU is 1 is no change. So that are the signals you are giving into the if it is 0. So if it is 1, so if it is the 1, so else it is the condition. If it is 1, so it will the happens first of all. If it is once, directly this will comes to the these signals, because in the description it shows that so here first two blocks, that means this block. So if it's in enable and axis one, it does not depend upon any other thing. Directly it is, if it is high, ALU1 is fed to the SRC1. Similarly, here other two blocks are depending upon the only enable X. So if it is 1, control is in, operation out, control in 2 out, operation out. So these three signals are declared here. So remaining cases, so here remaining cases is depending upon the opselect, because next block is in opselect. So opselect. We can see this opselect. So opselect is very simple. We know that opselect is size of 2 down to 0. That means 3 bits. So it from 0 to 7 it will count. So here we already declared that arithmetic logic, memory read, shift range are the three op selections from the preprocessor. So you can use this keyword like this. This is called definition format. So it is nothing but arithmetic logic, nothing but in definitions we are given that arithmetic shift is 3 with 001. So instead of writing 3 with 001, you can write the keyword like arithmetic logic. So depending upon the arithmetic logic, so you can see that arithmetic logic depends upon also control n. So depending upon the control n, ALU2 will appearing. So this block is nothing about to update the ALU2. So depending upon the control in 3, ALU2 will update. So here also depending upon the M2, shift number will update. So depending upon the control in 3, enable arithmetic will update. So like that, we are updating the enable arithmetic ALU2 shift number. So this is the thing we are considering the obsolete arithmetic memory shift register will update. So you will get the outputs of the NF shift number, ALU2, and everything. else case. So because here you can put default because so many cases are not covered, so you can put default is 0. So here enable access already we already registered noting with other cases we can put because else is needed to make unwanted latch in the simulation synthesis process. You are resetting the else part. So this is a code about a preprocessor. So the preprocessor are given as preprocessor.v as a file name. You are including that file in the top module. Top module is nothing but enhanced ALU. So your preprocessor.is included. So we discussed already defined preprocessor. Only last topic is ALU top. So this is the second block of the major top module. So this is we are going to design. Similarly, we have the ALU top because we have two subblocks. So you have to make it as a top level of the ALU. So in this you have the two subblocks. So this is the top module. You have to write the input and outputs. So you take this block diagram. This is like a top block. You have the similar things as in showing our main top module. So these are the inputs, these are the outputs. In between, you have the two blocks. To connect the blocks, only one select line wire is there and another shift out and automatic shift out is there. Okay, coming to this is the arithmetic block. This is shift ALU block. And as I said, this clock is of D flip-flop. So this clock is like D flip-flop to give a delay to the select line. So this is for that marks for D flip-flop. So depending upon the select line, it will select the arithmetic out or shift ALU out. Okay. So here select line is nothing but we will discuss the D flip-flop behavior first. So here D flip-flop is this one. We are giving the enable arithmetic as an input and we are taking the select line. So select line is directly nothing but enable arithmetic, but it will come after one clock cycle delay. So this is a separate file for the D flip-flop. You have to include it is not a problem because we are not using any definitions here. So you can include that is not a problem. So this D flip-flop file I am giving the name dff.v that I can have to include in the top module ALU. This is the ALU top. So here ALU top input signals and output signals are defined. So this is the arithmetic instantiation, shift ALU instantiation, and this is the marks. So coming to the ALU arithmetic instantiation, we will discuss this thing first of all. So subblock we will discuss. So this is the ALU arithmetic block. That means this is the subblock of ALU top. So can you see this one? This is the input. These are the outputs. Only one output. So I am writing that is one output. It is the right type because we are making it with the sequential. So depending upon the opselect, as we said, opselect is nothing but arithmetic or memory read in the ALU block. Only shift logic is in shift block. So according to the operations, this will select. So we gave you a meaningful name to the keyword already defined in. So I said I already discussed in the first edition is nothing but ALU1 plus ALU2. So here some mistake is there in this one. Here it is. It should be added and the sign is attention. So this line is error. It works, but it is not a correct logic. I will explain. I will make this correction and I will send the code. Not a problem. So these are the operations we can do in the arithmetic logic. So coming to the memory read, I already explained the load byte load thing. So according to the operation, it will select everything. These are in case. So yes, it will send the value arithmetic. So that is about ALU. There is nothing much discuss what we discussed in the ALU. So according to these signals, so ALU arithmetic is dependent on the ALU out operation. So ALU out will be the operations of the under or logics. So that's the thing, we write it in the case. Coming to the shift ALU also have only 4 things, not much things. So this is the shift ALU. Depending upon the shift operation, ALU out will be updated. So depending on the shift operation, so shift out is normally ALU out, we take another like that. So this is automatic shift. This is to do the automatic shift, you need to have the input as signed input. Otherwise, it will not work. Remember that thing. So we write. This is also have the definition, and we give the meaningful name shift ALU dot. So that two things is called in the ALU top, and also we included the two files. So these things. So totally we wrote first from the beginning. This is the top module and has ALU. It has preprocessor and ALU top. In ALU top you have automatic ALU, shift ALU, and D flip-flop as small thing to the ALU top. This is great. So to verify the logic, we can verify normally. Otherwise, you can write test bench for the code and you can verify the logic. So in this way, the project will work. So after writing the project, you just go to the enhanced ALU, simulate, this is the simulation, compilation, enhanced ALU. So once we enhance ALU, will give zeros or warning is something, then not a problem, warning. So 0 warning, 0 errors. So go to simulate. So this is enhanced value. Simulate, normal simulate. No need of optimization without optimization. Just simulate, it will do the with optimization only. So while compiling, it will compile all the sub-blocks because we already included the files. So adding the wave, so you will get the top level signals. What are the signals in the top level? It will come. So you can just force the input values, you will get the required output. See that the immediate signal is you are selected into the same thing or not. Yes, I see also. If you want me to give the description of the output also, just make a comment. I will make a video for this one. So thank you.